This is the first video of Module 1 of the Innomat Learning and Training Package, created for the Raw Materials Academy of the European Institute of Innovation and Technology. This first video gives an introduction to Life Cycle Assessment, or LCA for short. I'd like to start with a question about your buying behavior. Suppose you need a new pair of trousers, blue jeans. You go to the shop and you see two diesel jeans. Both have the same cut, the fabric has the same feel and touch, and the same color. Suppose the quality is the same and one of the two has a green sticker with the statement of diesel. This jeans has been produced greener than the other pair of jeans. Now, suppose you believe diesel. What I want to know now is, do you buy the jeans with the green sticker when both pairs of jeans have the same price? I will expect you to do so. But now the second question. Suppose the normal jeans cost 80 euros and the green jeans will cost 85 euros. Who of you will still buy the jeans with the green sticker? I will ask you to please be honest. Now it becomes a matter of priorities. Do you spend your money where your mouth is? In Western Europe, about 50% of students buy the jeans with the green sticker. Do you do so as well? I have one last question. Suppose the green jeans cost 90 euros. Who of you will still buy the jeans with the green sticker? Inquiries in Western Europe show that 75 to 80% of the people care for the environment. However, only 2 to 5% of the people are prepared to pay more for a green product. About 50% of the students do not buy green labels. They regard the label as greenwashing and mistrust the quality when the price is the same. There are two underlying issues. Firstly, how can you measure that the sticker is not greenwashing? This can be calculated by Life Cycle Assessment, LCA for short. This will be the subject of this first lecture. Secondly, how about the quality or value of the product? A lot of people mistrust the quality of green products and do not buy it for that reason. How to handle that issue is called eco-efficient value creation, which is dealt with in the last lecture of this training package. This first module has 3 blocks. I start the first block with the question, why would we make an LCA at all? There are people who tend to say, you should make an LCA because it's important, but many people might think, might be, but why should I do all the effort? In the second block, I will explain the calculation structure and tools. In the third block, I will teach you how to make a life cycle assessment of circular business systems. The other modules of this training package are Module 2 about how scarcity of materials is handled in LCA, Module 3 about the development of circular business models, and Module 4 about eco-efficient value creation for product innovation. I would like to come back to my question on the pair of jeans. People are both citizen and consumer at the same time. I am a consumer when I come to a shop and buy the best quality to price ratio I can get. At that moment, I don't think about environmental issues. I optimize my personal benefit, not the environmental benefit. This is the prevailing consumer behavior. However, when I'm hiking in nature, I have time to contemplate. I might think about my children and grandchildren, about their future, and that we should not ruin nature. In such a moment, I'm a different person than I am in the shop. In the shop, I'm a short-time impulse buyer. At home or hiking in nature, I realize what we should do in the long term as citizens. I realized then that we should ask our governments to make regulations so that it is forbidden for our industry to pollute the world free of charge. As a consumer, I am glad to buy all kinds of products, but as a citizen, I want the pollution to be stopped. So I want the government to put environmental restrictions on products so that I know that the products I buy are relatively clean. This is a slow process where via politics, governments can introduce regulations, step by step. Companies accept that, as far as these regulations create a level playing field in terms of competition. Regulations are of extreme importance in society. For instance, when you take away the rules in urban traffic, it will be chaos. That applies as well to the current free consumer markets with regards to the environment. But let's step back for a moment. The first basic question is, what is sustainability? This question triggers a lot of debate in science. One thing everybody agrees on is that sustainability has to do with the so-called triple P. It has to do with our planet, that is to say our nature, for ourselves and the next generation. It has to do with profit as well. But the meaning of this P is wider than profit. I prefer to use the word prosperity, since our society does not like to lose it. And it has to do with people. There are many interpretations of this third P. Which people? My opinion is that we should focus here on the poor people of the third world, the so-called bottom of the pyramid. The current situation is far from sustainable since these people don't have a fair share of the global prosperity. The basic idea of the triple P is that all these three issues must be okay for a sustainable society in the future. The idea is that you should make balanced decisions with regards to these three Ps. You should consider the trade-off between our economy and our ecology, and the trade-off between our own prosperity and the lack of prosperity in the third world. But how about the idea that it should not be a trade-off, but that we have to create a sort of new, better economy that reconciles all of the three Ps? The Brundtland Committee of the United Nations studied the issue of implementing sustainability. You will find the definition of sustainability in their report. But at the first page of the preface, there is a remarkable sentence. What we need now is an era with economic growth. Growth that is forceful and at the same time socially and environmentally sustainable. So the Brundtland Committee is saying here that we need a sort of new, clever economy where we can combine prosperity with much better care for the environment. A few years later, a group of big multinationals thought about it at the World Business Council of Sustainable Development. They developed a sort of general mission statement. The delivery of competitively priced goods and services that satisfy human needs and bring quality of life. And I stop here, since this is what you see in many mission statements of big companies. But they added to that, while progressively reducing ecological impacts and resource intensity throughout the life cycle to a level which is at least in line with the Earth's estimated carrying capacity. The basic idea is that we overload the Earth with toxic substances because of ever-increasing economic activities. Often these substances already exist in nature, but we simply emit too much of them, so our Mother Earth is not in equilibrium anymore. The third and fourth module of Innomat are on how to reconcile planet and prosperity at the same time, in the so-called circular business models and in eco-efficient value creation. But in this first and second Innomat module, we will talk about only the planet. How do we know that a product or service is good for the planet in comparison to another product? How do we know that a pair of jeans with a green label is better for the environment compared to the average pair of jeans? One of the observations nowadays is that nearly everything is called circular and green, but there is no guarantee that the product is really good for sustainability. Companies try to convince this with marketing messages that are easy to understand, but often not very accurate. NGOs do that as well, since they apply more and more to business-like marketing strategies and regard LCA as too complex for communication. But LCA is the only way to find out. LCA always has to do with comparison. We call that benchmarking. For instance, the comparison of a paper bag versus the reusable plastic bag. Which of these products is more sustainable or has a less environmental burden? The brown paper bag, since it's been made from recycled waste paper, or the reusable plastic bag, since it can easily be reused for many times. And how will the bags be treated at their end of life? Landfilled? Burned? End up in the plastic soup in the ocean? And what do we do when we apply biodegradable plastics? We need LCA, which is a well-defined way of analysis from cradle to grave or from cradle to cradle when we make processes circular. LCA is a technique that is used to quantify the environmental impact of a product system, good or service, throughout its life cycle from the extraction of raw material to product disposal. Life cycle assessment is about circular systems, as it is in the name and is shown in the figure. But the reality is that it starts somewhere, materials extraction from Mother Earth or from waste, and ends somewhere, landfill or waste incineration. It's obvious that we must avoid landfill and waste incineration by extending the product life and reuse, and by recycling of the product to a new product. So make the business system as circular as possible. Life cycle assessment is about mass and energy balances. It considers the entire life cycle of a product. It quantifies the required resources and emissions into the air, water and soil that can be attributed to the product. It also provides indicators of the product's contribution to environmental problems such as carbon footprint, human toxicity, toxicity for ecosystems, and resource scarcity. Now, what is life cycle assessment used for? First and foremost, LCA is used for comparison of products, like an alkaline battery versus a rechargeable battery, or fossil versus bio-based plastic packaging, or maybe a building made out of concrete versus a building made out of wood, and electricity from the grid versus electricity from PV cells. In the same way, processes can be benchmarked. For example, transport by train versus aeroplane, car sharing versus ownership of a car versus a bike, or centralized wastewater treatment versus decentralized wastewater treatment. LCA is also used for product design and improvement. How does that work? LCA shows which raw materials or processes contribute most to the overall environmental footprint of a final product. We call that identification of environmental hotspots. An example LCA of a knife. The steel blade and the plastic handle are both the environmental hotspot. Different alternatives can be evaluated in order to reduce the footprint of the knife, such as reduction of the blade's thickness, and recycled PP could be applied in the handle. In the use phase of the knife, hand washing and dishwashing are the two alternatives that have different consumption of water and electricity. The most beneficial way to employ LCA is in the early stages of the design. At that stage, the design concept is still flexible and allows for big changes, even in the business model. When the design of a product is finished, only relatively small modifications are feasible, resulting in only incremental improvements. Eco-labeling programs like the EU's are increasingly based on LCA. The most reliable and therefore successful eco-labeling systems is that of the Environmental Product Declarations, in short EPDs. EPDs are product descriptions with environmental information in a well-organized, trustable and transparent certification system. It's available in the building industry and will become available in the European food industry. It makes an end to the ever-increasing mess of labels. LCA is also used for strategic planning of companies. The basic idea is that a product has not only production cost and its market price, it also has the so-called external cost. We call that eco-costs. These external costs are related to the eco-burden of a product in the life cycle. The costs of this eco-burden are neither incorporated in the production costs nor in the market price. These costs are carried out by our society, not by the production companies, hence the name external costs. Fact is that the situation is not accepted by society, and the external costs will gradually be internalized by governmental regulations and taxes. The consequence for a company is that your costs will go up in the future when your product has a lot of pollution, either by extra measures to reduce emissions or by emission rights or taxes. In such cases, the company will go bankrupt. Examples are ever stricter requirements to reduce the emission of cars and carbon dioxide allowances for the industry. When you ignore the problem, it might suddenly cost you a lot of money, like Volkswagen, who ignored the NOx emissions for their diesel cars, which cost them billions of euros. The solution is an early product innovation. So eco-cost indicates the risk of not being in compliance with future regulations. It can also be regarded as hidden obligations for the manufacturing industry. LCA is also applied at the governmental level for development of long-term policies. Most of the governments apply for emissions the so-called abatement costs to determine their energy policies, subsidies, and taxes. There is a strong relationship between abatement costs, external costs, and the eco-costs in LCA. Governments are often involved in the communication of the eco-burden of products and services. LCA can also be used to compare alternative treatment processes of waste materials. Landfills should be reduced by creating a long lifespan of products, creating a business model that stimulates reuse and remanufacturing, design in a way that product materials can easily be recycled at the end of life, and when recycling is not possible, recover the embedded energy at the end of life, and lastly, to avoid disposal. LCA is well specified. The basics of the method are defined in the ISO 14040 and the ISO 14044. The Joint Research Centre of the European Union has compiled a comprehensive handbook on LCA of 400 pages, giving a detailed guidance on how to make a calculation. In addition to that, there are ISO specifications on detailed subjects. LCA is still developing in its details by scientific discussions. There are over 10,000 peer-reviewed scientific publications since 1990. However, LCA must also be doable. For that reason, the Delft University of Technology published a short handbook in which the LCA method is summarized and explained in an easy way. It's for students, designers, and business managers, and it deals with systems that are linear, cradle to grave, as well as circular, cradle to cradle. An LCA starts with the goal and scope definition. A good goal and scope definition is extremely important since it often determines the quality of the LCA. It must at least include the aim of the study. Is it a comparison of two or more products, or benchmarking, or is it the aim to improve of a specific product chain, hotspot analysis? Secondly, is it for internal or external use? And thirdly, is it to study a specific effect, for instance global warming or human toxicity? Or do we need a comprehensive environmental benchmarking study that combines more areas of production in one single indicator? It must also describe the scope of the study that must comprise the following elements: a system description including flow diagram, the system boundaries, what is included or excluded, transport scenarios, and lifetime assumptions, technical or economic. Last but not least, the goal and scope must contain the so-called functional unit, which is explained on the next slide. There are two sequential steps of the calculations. The inventory analysis, that is creating a list of substances from the mass and material balances, and the impact assessment, that is grouping substances with the same effects or areas of protection into indicators. An example of such an indicator is the carbon footprint. The last step in LCA is the interpretation, that contains the discussion and the conclusion of the study. The functional unit in LCA is the definition of the required output of the system, the delivery. It describes the product or service in terms of what, how much, how long, which quality. The functional unit can be very specific, like a technical specification of a bag, with a low freedom of design, or it can be more functional, like transport, with a high freedom of design. In some cases, the product can fulfill many functions, like a kilogram of steel. Then we call it a declared unit. The main aim of a functional unit is to make a fair comparison. When you keep that in mind, it does not cause many problems in practice. When you define the system boundaries of a system, you should start from an holistic approach. Include everything from cradle to grave and from cradle to cradle. The system has an output, which is a product or service, inputs such as material and energy, and emissions to air, water, and soil. In practice, you often do not have to calculate everything in the system. That is a matter of common sense. You might either be interested in a certain step of the life cycle, for instance to make a hotspot analysis of a production process. Or you might be interested in product benchmarking, where you're only interested in the differences between two product chains. When you exclude subsystems in LCA, you should always explain why. Either it is not important for the decision making, for instance when subsystems are the same for both systems in comparison, or the impacts are not relevant since they are below a certain threshold, for instance 1 or 2%. In the next assignment, you will experience that there is an enormous difference in the carbon footprint per kilogram of materials like steel plastics, bioplastics and wood. You will also see that the end-of-life processes play an important role, since there are enormous differences between landfill, the municipal waste treatment and upcycling. The first assignment will be to discover the differences between the carbon footprint of materials like steel, plastics, bioplastics and wood by using the Innomat app. I wish you a very fine learning experience with this first assignment.